This one, I will start from what is the bottleneck for this AI search. And then, actually, AI data center is really related with manufacturing. And then we scale in the connect capabilities, how to support this AI data center moving forward for next generation, how computing capability, higher power density. Then how we build up this kind of technology. Actually, it's not only single technology, it's moved to like the total operation architecture. Okay. Then turning this opportunity into action, give you some sharing, what the real side or demonstration side we can share in will reflect all this AI server manufacturing supply chain. The first one, I let you have some roughly understanding. 725 billion investment for CapEx for this hyperscale AI data center build up. No matter from the OpenAI, Amazon, Microsoft, Meta, actually this is a growth 77% compared with last year. So this huge investment only for 2026. Even for up to the 2030, it's trillion, not only billion, trillion one investment should invest for all this CapEx investment for this AI data center build up. But behind this, actually, how is the manufacturing supply chain to support this one? I think during this 725 billion, have the meaning number behind this one. So before we talk about the AI was the chip racing, now actually is the power and the supply chain racing. Because you see only 3 years from the H100, now we move to Rubin, Keeper, this higher power density, almost 1 megawatt, and moving to 800 VDC. This is really huge change. But how the supply chain should reflect for this huge change is really a difficult topic for the supply chain to fulfill this requirement to support time to market. Because I believe everyone now, you not use the Google, you use your OpenAI, you use your Gemini to ask the question. So this quick change, how we can catch up this, is not only the chip race, it's power and the supply chain race. It's definitely, from now on, it's already this trend. So move to the AI data center manufacturing. Is manufacturing objective. With the destruction, what is currently the AI raker? Actually, it's not a single case. It's one cabinet. It's now almost, currently is a 256 kilowatt. Later on, we move to 500 kilowatt. Then 2 cabinets combined together will become 1 megawatt. So the content in this cabinet, including the cold plate, including the power shift, including the switch shift, you can not only rely on the GPU have a higher computing capability, but you don't have the power to support it. You don't have the switch shift to support the communication. It's like you have the supercar, but you cannot drive on the highway. So this structure is quite important. The power cooling cabinet is already occupy more than 50% of the rack build cost. This is including all from the upstream to downstream supply chain. We have some advanced packaging, IC design related with semiconductor, which is quite stronger, already has a fundamental in Malaysia, right? And also have some key component. We talk about the cooling, power, and even the cabinet enclosure, the metalworking. This one also should support as the key component. Then the last one, I think also is the most important one, the assembly, testing, and packaging. Because now it's become the big size. It's not only the single pack. And then the testing should consume more and more electricity. Then will become the big issue, how to support this manufacturing. And behind this no matter from the upstream to downstream, the semicon to key component to assembly, the machinery and the processing equipment, how to provide the qualified component during this assembly also become the very important topic, including how to do the optical inspection, including how easy to pick and place for this heavy mechanical part, and the assembly precisely includes ensure the quality under risk control. So this is quite important for this AI data center. That's why I say actually it's a manufacturing object. So let's move to what is the most pain point, even in a different segment. For the semicon key component, now the PCB circuit board is become more and more layer. You need a more high quality to ensure when you insert the key component inside, each component, each chip, each the rack is same as the cost already is much higher than previous the consuming electronics products. So the common pain points for this semicon and key component, how can do the high precision, high task, high productivity, this high value PCB assembly is become the key task. Then how to trace in the quality during whole your manufacturing process, this become the pain point. The next one, you need to assemble the server system assembly. The common pain point will become how your unstable production cadence due to the frequent new production introduction. Every 2 years, 3 years, even the life cycle will shorter than only 1 year. This kind of revolution, you need a quick adapt for this server system assembly. Before have many cable, after Vera Rubin, you didn't see the cable. You have many connectors. So this will become another pain point or bottleneck during manufacturing, how to solve this. And no matter for the productivity, time to market, and also have the quality control. The last one, I think, is also the most difficult or most challenging for the manufacturing for the AI data center, the cabinet assembly, because each factory should consider the space. If you consider if you build up the 200 cabinet for the CDU, how many space you should evaluate, including your assembly and your testing. And another important one is how is your power consumption. You need to estimate it for your factory. And this heavy and the multi-component assembly, how to ensure this is a quality control, because this is not all related with the machine. You need to have the human and the machine cooperation to solve this. So that's why the factory or the manufacturing want to achieve this AI server manufacturing. We have the 5 connect capability, a scale, as I say. First, you need to have a connect. You need to connect, have the structured data, no matter it's string or unstring. You can structure it and collect to the database where management will analyze to ensure all the process is under quality control. And another one, due to the revolution, life cycle time getting shorter, you should build up the simulate capability to scale. Ensure before you build up the physical size, because you need a huge space to build up a physical size. How can do this during the simulation in the virtual space? Then you can understand if it is possible or how is the quality issue. And after this, you can optimize your production, utility data, then you can throw out reliability and the quality, energy intensive as one system. This is also quite important. Then you should assure this quality is under control. After assembly, how to do the testing, ensure the performance for each rack perform as well as the design. And you should test is also under the peak power. This is the most critical point. It's not run the general condition, but you should test in the peak power condition. Then last one, you can control, and then you can repeat this 5 connect as the positive cycle to have a scale factory for the AI server manufacturing. So based on this 5 connect, I can give you some idea what the current future trend we can support, or the factory should build up this capability. First one is how to connect the data to let your operation can visibility. No matter you have the structured data, is from the standard equipment, or you still have some unstructured data, no matter is the pitch feature, audio, or this kind of photo or custom file. You should collect together due to your age, because previously the pain point is the data treated by different machine, different product, how to connect. The difficult to connect production line, quality, and the maintenance information. How to centralize and become in your database is also quite important. Then another one is the AI model, lack of the constructualized operation data. This pinpoint, if we can use some edge data collection control, because you have different database, no matter for MQTT or OPC UA, this one, we have the solution to as the gateway to solve it. And you have some edge data management through the different protocol, no matter it's internet-based or it's the mobile space. You have some uniform protocol to support this. And the last one is EDS, how to do the edge data storage. Then finally, you can do the data fabric, data centralized. Then you can finalize, get the data governance to collect this data. It's quite important. Before you want to integrate all these manufacturing systems to support this quality control, it's very important to build up this data connection. The next one, as I mentioned in the second connect, how to simulate and scale. We can use the twin, which is now we talk much about the digital twin. Simulate first in the virtual world. We can start to simulate each station, how to pick the robot arm, how is the cycle time, and how is the real precising compared with your real mechanical part. Then we can come to the real world to see this is shorter the time to market. Because during the simulation, you can pi run, you can do in an MPI in the virtual world, then you can ensure when you deployment or implement to the real world, everything is under your control. So this is something we really use the one-to-one from the virtual one and finally deployment to the real world. Next one, I think after the simulation, we talk about the previous slide, we talk about the single station. We talk about the machine twin. After a machine twin, you can build up the line twin as this full production line, as the one production line end to end. Then after this, each station, you can build up on each station, use the simulation to understand. Then after the line twin, we have the factory twin, which is based on like the Omniverse. This is a platform as a service. So you can see many suppliers, no matter for ANSYS, for the SolidWorks, for all of this software simulation is joining this as a service. Delta also is one of these service provider. We have the digital twin, we so-called DIA twin. We are also under this Omniverse platform. Once you build up this by machine twin, you can easily implement to the line twin and the support to the factory twin to monitor or to simulate each station and collect data under your database analyze. Then after you can simulate, how to ensure you can assure and optimize your process. So this is the only kind of the example of the production line for the L11 assembly for the AI server rack. So from the A1 to A9, all station, each station should have some people and work with some collaborative robot. We so-called is a human-machine collaboration. Later on, I will show you how to do this. Because this kind of assembly cannot rely on fully machinery to support. Something is very heavy, you need some crowbar to support you to pick up this, but you still need to have some operator to ensure your installation is quite precise. So this is under the control from the feature, and then human-machine collaboration, then how to use the fully automated robot arm to support you to doing the inspection. So different purpose, we have a different process. We found the process operator self-inspection, then finally go to after the A9, we have the quality control station, then we move to the final test of the quality control station. This should embed it with the input, for example, if you use the 800 VDC, you need to input the water to do the liquid cooling to test this AI server rack is follow the performance as the design. So how to do this dynamic inspection? So we have the camera, but this camera is not only take the photo or video it, actually is embedded with all the operation instruction. Then we have the AI to monitor if this operator follow the operation instruction to assemble each step of this station from A1 to A9. No matter it's the screwing, cabling, or plug the connector. So this one can ensure your action detection. Do you have any wrong part number detection or miss any part in this installation? Then also monitor your position verification. It's quite important to ensure all the AI server record during the process is 100% under monitoring. Then we can ensure the quality control. Then after this, when we do the before we do the final quality testing, we have the use the fully automated robot to detect, no matter from the gauge, analog gauge, the meter, and the barcode check, and also during the testing, we can check the leakage. Because now it's moved to the water cooling, this one we also can detect any leakage. Then all this can rely on the robot combined with the vision system to do this. It's fully automated. So this inspection can ensure your inspection percentage more than 90%, and also reduce your cycle time. Before, without this kind of automated inspection, maybe per day, our productivity for each raker less than 10. After this, I think per day can enlarge around 51. So this is a huge improvement, and also improve your productivity. Also, the labor reduction. And the labor reduction is only the cost issue. Another one is the AI vision can help you to monitor to inspection better than the labor inspection. Okay. Then after you have the simulate and you really build up the line to do the production, and now you also have the testing to ensure the quality. Finally, you still have the system, which is connect not only for the facility one, because during the assembly, you need to use some air compress, you need to compress air, you need some HVAC system to ensure all the piping, the cooling system can work well. But we know now the AI server is moved to 800 VDC. You need to have some HVDC supply, power supply to help you to testing. So actually in the future, the factory system is no matter from the facility or from the production line, actually will become the one platform. So we are not only, we talk about the facility monitor control system. It's not only pure talk about the facility. We also should involve your testing equipment, your testing facility on your production line. No matter for HVDC or you have SST, this one also can under this monitoring, ensure whole the system is a centralized factory system to ensure the production is no issue, the facility is support well. So this is the last connect we talk about. You need to have the one platform to monitor all the system, can assure, and then you can rebuild it to ensure all the quality under control. Okay. So this is some all the portfolio. When I talk about in the previous slide, from the simulation to the assembly to the AI inspection to the fully automated robot arm inspection, including actually this whole solution we talked in the previous slide is including the product. You need to have some product, no matter for a robot or some equipment or some screwdriver to support you. And you also need to have some surveillance, no matter it's the CCTV camera or you need a HVDC, you need a SST. This is product label. And you need to have some machine to support your fully automation. If not the cabinet assembly, for the PCBA, definitely you need some automation equipment. Then move to the edge label, you need to have some software as the edge to collect the data. And the collect data you should through different protocol to ensure everything, every machine, every station, you can collect right data to your data fabric. And move to the system control level, you should have some SCADA system to monitor, and you use some twin from the machine twin to production line twin to factory twin to monitor all your factory. And finally is move to the IT. You need to have some MES to connect to the ERP. So this is the whole structure. Actually, we already say this AI server manufacturing, this is the total end-to-end operation architecture. So if we, according to our understanding from this one, we need to consider we have product, we have equipment, we have software, we need to integrate together. And in the future, in your factory, you are not only the single supplier. You have the SI, you have the plant manager, you also have an equipment provider, your component provider. How to collect this, become the one platform? I think this is the final operation architecture for your reference. From the equipment, product to software, then we can deliver to support the AI server manufacturing, can turn to market to support this AI data center revolution in near future. So this is my sharing today. Thank you, everyone.